right. Let's take the third question, right? Ngwe.
The distance xm traveled by a particle in time.
Distance xm.
Traveled by.
Why is it xm? Meters. Distance measured in what? Meters. Is given as what? Traveled by
a particle in time. T seconds is described by the equation x equals to 10 plus 12t.
10 plus
squared.
10
Plus
okay 12t what? Squared, right?
Find the average speed of the particle
Average speed of the particle.
between the time interval t equals to 2s and t equals to 5 seconds.
The first one, t1, is 2 seconds, right?
Yes.
Between, that is what we need to take into consideration. Between t1 equals to what? 2 seconds, right?
Yes.
And
T.
t2 is equals to what?
5 seconds.
5 seconds, right? Not 10.
Yeah.
5 seconds. Good. We've got a problem here. Find what? They say we should find what?
Find the average speed of the
The
particle.
average speed. So we can do that by saying average speed, or rather, VAV is equals to what? What do we have? How do we get this? It's change differentiation of x over what? Over what? T. This one has you are a bit confused. This has to do with differentiation, yes. Why is it differentiation? You need to differentiate. Remember that normally you have speed of velocity equals to what? X over what? T.
Yes.
Huh? There's no problem. Now, this x now is represented with this ordinary x. Okay? That looks like a star, right? So in place of this, we have this. And the t, we have this. The only difference here is that we have what? Differentiation of what? X over differentiation of what? T. What it means that what you have, this thing you have, which is given as this, differentiate it with respect to what? T. That's what this means. And if that is the case, let's see. Don't be scared. When it is like this, you've started well. You have shown them that you know what to do. With this, you have shown them, or rather you have shown the examiner you know what to do. So what it means, put your value. The value you have is what? 10 plus what? 12t what? Squared, right?
Yes.
It's not true?
Yes.
That is it. They say differentiate x with respect to what? T. That's meaning. If you have done differentiation before, it means whatever you are going to do with x must also affect what? T. Or whatever you are doing, do it in respect with what? T. So, we don't have t here, right?
Yes.
But we have t here, right?
Yes.
It's not true. So what you need to do at this point is very simple. First of all, put down 10 plus 12t squared. That is what you're looking for. I know this will be a bit technical, but watch what I'm going to do now. When that happens, you write your x, measured in meters, is equals to 10 plus 12t squared. You are now differentiating with respect to t. What it means, any change in x must also lead to change in what? T. Okay? Just hold on. So we go dx over dt. That's what we are interested in. If we differentiate any constant number, look at this number. This is 10, right?
Yes.
According to law of differentiation, any constant number you differentiate vanishes, becomes 0. Okay? Don't worry. I'm going to guide you more. Becomes what? 0. But here, look at this. These two will come down. These two, okay? We come down first and multiply 12, okay? It looks this way, right? And then you put again t, that 2 minus what? 1. Take it again. Let's take it again. Any constant term you differentiate turns into what? 0, right?
Yes.
Okay, you can see this side. Let's take this side. Xn is equals to 10 plus what? 12t what? Square, right? Let's go. We're going to differentiate x with respect to what? T. Meaning any change in x must affect what? T. Must lead to change in t. That is time given. So what we need to do is very simple. We differentiate any constant term. Constant term is a value without what? Letters like x or y. So there's no coefficient here, right? There's no letter here. So it's a constant term. When you differentiate it, it becomes what? 0. That's the first thing. Then the second one is this. According to law of differentiation or rules guiding differentiation, the one you have as power, okay? Bring it down. Are you there? Hmm? Times it with the coefficient of t. I hope you are following this. Or rather, let me bring it down here. We have 0, we have plus. Then the power, bring it down. This is it. Times it with 12. Are we there?
Yes.
Put your t and then that 2 minus what? 1. Check it again. Let's take it once again to avoid confusion. When you differentiate a constant term, it vanishes. That's the first thing you should know. And that is this. Now we put our plus sign, move on to this one. The first thing we need to do here is to bring down the power. The power here is what? 2. Use it to multiply this. Becomes what? It becomes what? 12, right?
Yes.
And that's 12. You bring down t. Go back to the power again, minus 1 from it. So at the end, what do we have? We now have this goes, right?
Yes.
2 times this is what?
24.
24. Sorry, 24. What remains here? 2 minus 1.
T.
T remains. You keep it. So you now have the x over dt is equals to this. But there is something given to you. They say that the time t1 is what? 2 seconds, right?
Yes.
T2 is what? 5 seconds. What comes to your mind? Average speed. Average speed. So what do? Wherever, anywhere we see t, we put what? The first time we put what? 2. The second time we put what? 5. Am I making any sense?
Yes.
Don't worry, you're going to understand it. At times it's like that when you're encountering new terms. So let's go. We now have dx over dt is equals to what? 20 what?
24.
24t, right? When t, there is, you can say when t is equals to 2 seconds, what happens? Put t there. What do we have? It becomes 24, right? Times 2. What happens here? 48, am I right?
Yes.
48 meters. We keep it. Hold on, we keep it. We keep it at this point because we have used to, right? Take notes. Take notes. We keep it 48. Then come here. Let's see what happens here. When t is equal to what? When t is equal to what? 5. What do we have? 24, right?
Yes.
Times 5. What is it? Should be
120.
120, right?
Yes.
120 meters, right?
Yes.
Look at this. 120 plus 48. What do we have?
We have 168.
168.
Yes.
Check the option. Do we have anything like that? Quickly. Do we have anything like that?
No.
Nothing like that.
Yes.
Now hold on. You have done the first step now. Now look at another one. Look at this. You have T1 is equals to 2, right? Seconds, right?
Yes.
T2 is equals to what? 5. Are you there?
Yes.
And the dx over dt is equals to 24 what? T. Okay?
Yes.
What's the difference between T1 and T2? That's 3.
Yes.
5 minus 2 is 3, right?
Yes.
Okay, let's go and see. 24, whenever we see T, what do? We put 3. 24 times 3, let's see. Quickly.
72.
Do we have 72 there?
Yes. Yes.
Huh?
Yes.
Okay. means the average speed is equal to 72 meter per second. Soft. Okay, that is it. So let's see. Look what kind of number I like. Yeah.